Okay, so I want to go back to where we picked up after the midterm. So these were like the solutions to the midterm here. So the exam will be similar to most of my exams. So there'll be 10 questions, 10 points each, designed to take, an hour or something like that. You'll have the full 2 hours, whatever, to take it. Actually, I think I mentioned at the end of class last time, because I'm not sure I'll be back from my flight in time, I'm going to put our test online. So because sometimes I know Blackboard can be quirky, I think I'll probably just put the time limit at like 4 hours or something like that. Or I might not even put a timeline. I'll see what options it gives me. But time should not be an issue on the exam. You take as much time as you need. Just don't cheat. If you need to use a calculator or something like that, you can. But I'd rather. Hell, now I'm in the habit of standing classes up, so it's, I guess, a new thing. But in any case, it'll be available. I'll probably make it. I'm hoping to make it available by Friday night, which in my mind was by tonight. Now it'll be by tomorrow night, because my flight leaves really early on Saturday. So if you really wanted to do it, you could do it over the weekend ahead of finals week. That's my intention, is to have all the exams written, and that's actually mostly Maddie's fault because she wants to take 450 earlier, so now I have to write that, which is where the GR was from. So now it's going to be extra hard exam. That's a, you would or would not appreciate that. Well, then I have to curve it. Maybe that's better.
So I just have to be smarter than the
It's just like on a bear attack. You just have to outrun the you got to outrun the next guy. All right.
It's hard because I don't know who's all in my class, so I can't gauge their strictness.
Well, you just have to be better than like the average.
Just have Shiva take the final. They'll bring down the average.
Well, Shiva's bright. He would do okay in that final.
Yeah.
You don't know Shiva, do you?
No.
He's one of our MSIT students that graduated. He's bright. He would do all right in
You
there.
have that on recording.
Huh?
You have that on recording.
So? Did I say anything bad? I said he's bright. He would do all right in the test.
Yeah.
Okay. So, since the midterm, we really have been designing this this game type thing. So thinking more of a project from the perspective of object-oriented programming with some database stuff. Now we've learned some thread stuff. So you should be very comfortable with the idea of if I give you a question that says, create an object to represent something. I might give you a paragraph and say, create a set of 2 or 3 objects that you'll need for this, and show me that you understand how to do that. Like if you needed to represent, for instance, in this case, we represented a room. You decided a room maybe has a name and a room has a description, and a room has a collection of exits, something like that. So being able to imagine objects in terms of you turning real life problems into a representation for object-oriented programming. So this is kind of our example there where we went through and we designed what a room is, we designed what an exit was, understand the idea of an abstract class. So abstract meaning a class that you cannot instantiate, so its purpose is for inheritance. We used an abstract class to represent our character, and then we extended that through the inheritance model for our player and our NPC. Right? All right. So understand the purpose of abstract classes. That might come in the form of what does it mean for a class to be abstract? It might come in the form of write an abstract class and then extend it with 2 additional classes, things like that. So there will probably be at least a couple of questions on there where you'll have to write 2 or 3 classes for on the exam, and maybe I would say that you don't have to create the getters and setters or something like that. just so you don't have to write tons and tons of text, but show me that you know how to define a class, with its constructors and things like that. A question like that might not even have any real logic in it. It might just say, show me you can create fields, you can create a constructor, and you can create a class, and then maybe even show me that you can create instances of that class. That aspect of it, as opposed to solving some logic problem. You won't have to do anything with, building interfaces and things like that on Android. That's more of just a means to an end for our applications. Understand the idea of hash. We talked about hashes being one-way ciphers in here. Book talks about hash maps, or hash tables, I think, in the book. We've looked at hash maps in here. I probably won't have you problem solve with a hash map, but you should understand what, there could be a question, something like, here's an example of a problem. Which of the following data structures would be the most appropriate solution for this? Or how might you use each of these 3 data structures to solve this problem? I have to write a sentence or two describing how you might apply that data structure to that problem. Make sense? So understanding that a hash is basically name value pairs. So you get a key and you have a value. There's a chance of a collision, but that's not really founded that often for most of the problems that we're necessarily solving. But it allows you to have a key and have a value associated with it. Collisions only really occur when we're dealing with encryption. Kind of the common use of a hash would be MD5, where you have a 5 gigabyte file, you shove it through the MD5 hashing algorithm, it gives you this single number in the end that says whether or not your download was likely good or likely corrupt. It's not a guarantee, but there's a really, really, really low chance that your file got corrupted in just the perfect way to give you the right output anyways. But for us, if we're using this in a solution for a program, more often than not, we're creating, a list of, apple, pear, orange, and then, having numbers or something like that for the value. So we're in control of whether or not we have more than one key that matches. That makes sense? So not really an issue for us. But understand the use of hashes, whether it's hash table, hash map. The implementation behind the scene might be a little different, but the problem-solving approach for them is the same. Certainly understand Firebase. I wouldn't have you write code for Firebase stuff, but I do like putting on exams, like here's some code, tell me what it does. So I could see giving you an example with Firebase and making you understand that nature of it being an asynchronous call. And I might say, what will the output of this program be, or something like that, showing that you understand that the stuff that happens after you create the listener will happen first. And the listener only gets called back when Firebase finally returns. So that's like a promise for something to happen, in several seconds or something like that. It's a non-blocking call. So that would probably be my easy way of testing whether you understand the idea of a non-blocking call, an asynchronous call, and how your program continues on. Okay? So you won't have to write Firebase code. You don't have to go and memorize the stupid setting up listeners and things like that. Most of the syntax you'll write on the exam. There'll be plenty of programming on the exam. In fact, I would say most of the questions will probably involve programming at some level. There might be a couple that don't. They're short answer or something like that. But most of them will be programming. They're going to be more logic drill type stuff. So, think back to like the exams in 250 where, you're asked to write a method that does this or write a method that does this. I would expect you would be able to write more complex methods now. You should be more practiced with logic and things like that. But I still wouldn't ask you to do incredibly difficult things. So, I would ask you stuff that would be harder than like reverse a string, but it might still be string manipulation stuff, array manipulation stuff, working with linked lists or stacks or queues. A lot of times what I do with those, I like to kind of say you can assume you have a linked list, a stack, a queue with reasonable methods, so push, pop, peek, those kind of things. So that way you're not, you can call a method that would be reasonable for it to be there, get at index 2 or something like that, and have you solve problems with a stack or a queue, that kind of stuff. But expect the methods that you'll write to be more complex than like reverse a string, but less complex than like write merge sort, which merge sort's not that difficult at the end of the day, but I probably wouldn't have you write that on an exam, because that's one of those things that sometimes you need to run it and you see like, oh, I see where I screwed up here, and you fix it. But so I probably wouldn't ask you that on an exam. Understand the concept of a closure. That could come in the form of, I might ask you what that is. I might show you some Firebase code or something like that and ask you to circle where the closure is or something like that. Be able to identify a closure if you see one. Again, asynchronous versus synchronous, blocking versus non-blocking, or non-blocking versus blocking calls. Okay, so let's go back before the midterm. Certainly understand the difference between an array and a linked list. That I don't know if that would be a direct question where I'd ask that, but you should certainly understand the idea of linear and nonlinear linked data structures related to linear data structures like arrays that exist in memory that's all in a row, contiguous memory. Be able to work with linked lists. It would probably be fair game for an exam for me to ask you to write a linked list that has you supports the functions for add front, add end, something like that. Similarly, maybe write a stack that supports push, pop, peek, that kind of stuff. These are fairly simple functions to write. What I probably wouldn't put on an exam is like add or remove from like the middle of a linked list. Not that that's incredibly difficult, but that's more picture drawing and things like that. Just I would want you to show me that you understand the idea of having a pointer to the front of the list and that kind of stuff, and be able to work with that. Understand the differences between linked lists, stacks, and queues, how stacks and queues are special purpose linked lists. Stacks are last in, first out. At least I beat him to class.
Gee, troubles.
I was 20 minutes late, and I still be here. I was sitting in my office. All right, so by the way, you get a free quiz.
What?
You showed up late, and you still get a free quiz. Because I was late, so I'm giving everybody a free quiz. All right, so so a stack is a last in, first out queue. A queue is a first in, first out, kind of equivalent to our real life idea of a line. So I could give you a problem and ask you which of these data structures is the appropriate one to solve this problem with and why. That kind of question. So understand when it's the right tool for the job. Understand the use of the instance of operator. I'll probably make use of that on the exam in one form or another for determining when something comes out of a linked list. If you have a linked list of like generic objects or a linked list of maybe an abstract class, determining when you pull that object out, what is it actually an instance of? For instance, in our, I guess pun intended, in our setup for our game, we have an abstract class called character, and we have two classes that derive from that. We have player and we have NPC. Well, you could create a linked list of characters. Now, we know that you can never actually have an instance of a character because it's abstract. Yet you can throw players in there and you can throw NPCs in there. So then I might ask you to go through that linked list and tell me how many NPCs there are and how many players there are. Where you would go through the linked list, pull each thing out, ask, are you an instance of a player or are you an instance of an NPC, and increment some tally. Something like that.
So
Yeah.
like you like if like whatever the linked list part is, so then you'd say equals instance of in parentheses NPC. Is that how
No equals. It would look like, if ll.get from I, so that's going to be your object. If that guy is an instance of player, something like that, then you would say, players plus plus, that kind of thing. This instance of is a Boolean operator that returns true if this dude is one of these dudes. Make sense? So that's kind of our nice little power tool that allows us to store objects generically and play the kind of the inheritance hierarchy game, and then make the decision of whether or not that player, or whether the thing that came out is this guy or some other guy, if you want to store things generically. And that's only going to be, acceptable in certain situations. You might be, for instance, creating a generic linked list for a project. Let's say you have a project that's going to hold, you're going to need linked lists for all sorts of different objects. Generally speaking, you're probably only going to store one kind of object in that linked list when you use that linked list. You might store only players in there, or only NPCs in there, or only something else in there. So with that in mind, you could have a linked list that holds objects. So everything you throw in is generic. That way you only have to write the thing once. You have a single linked list data structure that you can throw anything that is an object in there. Now, you wouldn't have to, if the way you use that is to only hold players or to only hold NPCs for a moment, you don't have a mixed bag of things in there, then when they come out, you don't need to ask, are you an instance of whatever? You just have to cast it to player or cast it to NPCs so you can call the methods on that. Otherwise, it's going to treat it as a generic object and say the only method you're allowed to call or are the objects that come with generic, or the methods that come with generic objects. That makes sense? So the punchline would be, it would not be a bad idea to create a generic linked list that could only hold objects, to give you a very convenient tool that you can use whenever you wanted to, and just give you the inconvenience of having to typecast when you pull stuff out. But in some weird world scenario, when we want to have a collection, well, actually would make sense for our current game. Right now we have a linked list of players and a linked list of NPCs, right, in our room. We could just have a linked list of characters that inhabit the room. And as we pull them out, we can decide, are you a player or are you an NPC? Rather than having two linked lists, we can just have one and store all the characters in that one linked list. And then if we need to differentiate between them being players or NPCs, we can do that using the instance of operator. That makes sense? All right, so it's possible I would have you write code to use instance of. It's also possible that might find its way into like one of those questions where I say, here's some code, tell me what this does. I mentioned this in my other classes that have those kind of questions. When I give you questions like that, it's fine if you go through and say this line does this, this line does this, this line does this. But what I'm looking for your final answer is, what does this chunk of code accomplish? This finds the maximum value in a list. This counts the number of players that are in the list, that type of thing. I'm pretty confident that on a line by line by line basis, you guys can tell me what this particular single line does. I want you to be able to read a chunk of code and tell me what logic does that solve. That make sense? So those are the kinds of answers I'm looking for those kinds of questions. I mean, we talked about the mathematical precedence stuff when we were talking about the shunting yard algorithm. So this isn't is that even spelled right? That's a weird spell. Must be right, but that's a funny looking word, isn't it?
Too many E's.
Maybe that's it. Feels like they should just make this one an A just for fun.
Right, and that second E should be an I.
Yeah. That would be better. Well, all of you really should know this already, right? But I'm not going to, I can't imagine testing this directly. I mean, that's just the rules of math. You know, the addition and subtraction come after multiplication and division. Otherwise, within those, it's left to right. So, I mean, it's certainly fair game for me to assume you know that. I would come up short of assuming you know like order of operation for like powers and things like that. I think that they're more important. So I think powers come first, but other thing, like parentheses, if something's in parentheses, you do that guy first. He's super important, right? So you should know kind of common mathy stuff, right? But I won't test you on that specifically. That's just something you should know. All right. Similarly, we talked about the shunting yard algorithm. I probably would not test you. You don't have to go and memorize that algorithm. I mean, at the time when you were writing it, it was pretty clear to you, but you haven't thought about it in a couple of months now. So don't go back and rememorize shunting yard. I'm not going to test you on that on the exam, but if given a problem, not as complex as that, because that's kind of having to use cues and stuff like that. Not that it was that difficult, but you had a lot of moving parts for it. But given a problem along those lines, you should be able to follow, show me that you can create an algorithm for something. Okay? But you don't have to go and memorize how shunting yard worked. That's not the type of thing I'm testing you for. I'm really testing you for programming competence where you should be graduating from 300, in terms of your programming ability, that type of thing. This is our stuff. We did talk about generics. There's a possibility I could give you something on the exam where I probably wouldn't have you use generics on purpose, but you could probably choose to use generics if you wanted to. So for instance, if I mentioned that you have a stack that is capable of holding generic objects, for example, and I ask you to solve a problem in terms of that, and so now anything you throw in there that's an object is going to come out as a generic object, even if you threw in a player or an NPC or an apple or a pear or whatever it was. It'll come out as a generic object, and you would then have to cast it back to its type. If you wanted to, you create that stack in terms of the generic syntax where you said, this is actually a stack of apples. Then you could assume that when they come out, you don't have to cast them back, because that's what generics does. Generics makes them come out as the type you advertise this generic data structure to hold. Okay, so that would allow you to have a little more convenience on the exam while also showing me you understand generics, which I would probably say is one, like a +1 for what you need to come out of 300 knowing. I don't think generics is something that is like a requirement of understanding coming out of 300. But if you're comfortable with them, feel free to use them. Otherwise, just do your typecasting thing and move on with life. All right, so I won't test you specifically on generics, just because it's not a piece of knowledge that I necessarily care if you've mastered at this point. It's a convenience. It's syntactic sugar stuff. Nonlinear linked data structures, trees, and things like that. You should be able to solve problems using binary trees. you really should be able to write a binary tree as well. I mean, almost all of our data structures, if you think about them, were not very difficult to write. Most of them had that one little piece, like add or remove at index for like linked list that is more complex, but add front, add end, those are easy, right? Especially add front. So stacks are super easy to write. Everything's add front, remove front, just look at front. So those are really easy ones to write. So those are things that you might be asked to write on the exam. Same thing with a binary tree. Writing a simple binary tree on the exam would also be fair game. I could ask questions about how tree traversal, in order, post order, pre-order, those guys. I might say, here's a binary tree. Tell me what the output would be if you were to visit these in order, pre-order, post order, those guys. So here's your pre-order, in order, post order. So given a tree on an exam that looks like this, I might ask you to produce these things. I mean, searching for data on the exam would be fair game. I probably wouldn't have you, most of you would probably just default to a linear search, just move on with life. So I don't think you need to have memorized binary search. It's not a difficult thing to memorize, but I'm not testing that type of thing. You can go and look up the algorithm for a binary search if you ever need it, and then write it real quick and move on with life. So I won't test you on specific stuff like that, but it would be reasonable for me to say, here's a linked list or here's an array, find how many 7s there are in there or something like that. You should be able to run through it and search for stuff, however you decide is the best way for you to search for stuff. So related to merge sort, again, I probably wouldn't ask you to do anything related specifically to merge sort, but you should understand recursion. So it would be fair game for me to ask you to either read a recursive function, but in 300 you really should be able to write simple recursive functions. So it would not be unfair for me to ask a programming question to solve some, write some short function that must be solved recursively. And I would give you something that was kind of compatible with recursion. So you would have to know what recursion means and know how to write a function that follows the rules of recursion, and then be able to imagine the solution to the problem I'm giving you recursively. That problem would probably be a pretty simple problem, simpler than some of the other ones in terms of its individual complexity, but you still have to do it recursively, which then adds that little complexity into it. Make sense? All right. So merge sort being an example of recursion, but and anything I asked you to write recursively on an exam would just have one call to recursion, because one of the scary things about merge sort is when you have the double call to recursion. Once you get very comfortable with recursion, you realize the two calls on the left and the right half isn't actually a big deal. But early on, recursion is kind of a brain infinite loopy type thing. So anything I asked you to write recursively would only have a single call to recursion. More of like baby steps. Like, do you kind of get recursion? You'll get very, very, very good at recursion when you take 470, to the point where you'll come out the other side and have trouble solving things iteratively. Because really, anything that you could write as a loop, you can write it recursively. It's inefficient, but in a language like Scheme, which officially does not have a loop structure, but they've built one. It's implemented recursively, but you have to solve any problem that requires repetition through recursion. You call the function again, passing to the next value. Whole tree traversal stuff, like I said, those are fair game. I wouldn't do anything with tree balancing stuff. Understand, it would be fair game for me to show you a tree and ask you, is this tree balanced? That's when the depth of the left half and the depth of the right half are within one of each other. Otherwise, it's unbalanced. And an unbalanced tree ultimately means that a tree is not efficiently searchable all the time, something like that. The book does talk about, I think the book talks about AVL trees, but we didn't actually write them. We talked about them at the high level, but we didn't write AVL trees. That was right before the midterm, and then we went into doing a larger object-oriented application, which is fine. I probably wouldn't test you on AVL trees anyways on the exam because I kind of advertise them as in class as they're complex. They're not difficult to use if you already have a rebalance algorithm. If you just have a function that says rebalance the tree, then every time you add something to the tree, you ask the question, is tree out of whack? If yes, call rebalance. Good. Now it's not out of whack. It's balanced. But writing that self-balancing function is complex. Okay, so that gets us to the midterm stuff. We have recently talked about threads. I have a feeling threads will make it onto the exam for one question probably. It might come in the form of a question where I say, tell me what this code does. It might also come in the form of you having to write something for threads. So you should go and make sure you know how to create a thread and start it. That's not very difficult, right? You just extend thread, make a public run method, and then call start on your instance of that guy that calls the run method. So something like that I think is fair game for me to assume that you would memorize those couple of little steps, as opposed to like with Firebase where you have kind of the crazy listener thing you have to attach to. Not a big deal, but you're going to copy and paste it most of the time when you're writing it. So I wouldn't ask you to do that. If I asked you something with Firebase, I would give you the code and say, what does this do? Something like that to, test asynchronous calls or something like that. But the same thing could be true with threads. I could use threads as that example of blocking versus non-blocking calls as well. Okay, questions about the exam? Yeah.
So are you putting it like on Blackboard in the sense that it's going to be actually on Blackboard, or are you uploading a document?
I think what I'll do for simplicity's sake, because I don't know if you can completely rely on Blackboard for, let's say, obvious reasons. But B, you might want to like type stuff up in your own editor or something like that. So I'll probably just put up like the PDF of the test, download it, whatever, probably get it off Blackboard as soon as possible. That way, in a case where Blackboard goes down during finals week, you can just email it to me or something and we'll make it work.
So then you want us to type it?
You're free to type it. Yeah, if you prefer to handwrite it, you can, but just solve it and send it to me in whatever way is your preferred method. Sound fair? Yeah, because like I said, with like most of my exams, I'm looking for competence. And, I'm telling you don't cheat, but you're only hurting yourself. So at the end of the day, show me what you're capable of doing. I'm not grading for perfection. I'm going to make the assumption that you didn't compile any of your code and test it and things like that. So I want you to write it off the top of your head so I can kind of see at what point are you on relying on pre-written code versus being able to write stuff yourself. And I'm going to test you on things that you should be able to write yourself. So anything that I would assume that you would have to copy and paste from something else, I would either not have on the test or I would give that to you on the test. Because that's not what I'm looking for. I'm not looking for your skill in copying and pasting. That make sense? All right, what else? Like I said, I'll try to have that up by end of day tomorrow so you can just decide when it's most convenient. I'll just say have it done by the end of finals week. So you can decide when you need to squeeze it into your schedule with all your other studying and things like that. Because I don't want to risk my flight getting canceled or coming in late and then not being here for the final. Huh? Alabama for a conference. But if you're in any of my other classes, really bad things would have to happen for me, like crashes and stuff like that, for me to miss the exam. So if you're in my other classes, because there was like a rumor that all my exams are online, they're not. For my other classes, you show up to the exam time, and that's it. If you do need to, I mentioned this in my other classes, if you do need to take an exam earlier in the week, as long as it's Wednesday or after, I could probably make that work. Because like one of my exams is on Friday, and I know some students might be done by Wednesday and don't want to wait 2 more days to take that last exam. That's okay. Email me, we'll figure it out. Okay? All right. Any more questions about the exam before we go over to wandering NPC guy? We're good there? All right. Perfect. And if somebody would remind me, I'm going to try to do the free quiz by tonight as well. So if it's not up by tonight, let me know, because I want to make sure I do that, because it's one thing when you're a minute or two late to class, but when you basically forget about class, it's not something that I want to make sure I provide an apology for that. That is not my intention. Huh?
You haven't missed any classes.
No, it's kind of common where I get stuck in the hall talking to a student or something like that, so I might wander in a minute or two late, but pretty uncommon for me to miss a class and not have told you that I'm really ill or something like that. So it's kind of funny that I was.
Saying, like, there hasn't been a day that you've been sick this semester.
No, I don't think so. But yeah, so I do apologize. It's no real good excuse for sitting in my office while 20 minutes of class burns. All right, so let's go write our wandering NPC dude. Shouldn't have been too terrible, right? Not a big deal. Is it minimized? Yeah, it's minimized.
Just actually random in what exit he takes. It's kind of weird.
Okay, yeah, we'll look at it.
Just getting the first exit he's not available.
Yeah, and then, so I think that, and then making sure, probably the way I'll do it here is every single time an NPC moves, I'll probably refresh the main screen, whether he moved into that room or not. Does that make sense? So you have these NPCs that are all over your map, potentially, right? Every room has an NPC in it, or might have one or more NPCs. And these guys are gonna, every so often go from room A to room B. Well, room B may or may not be the room that the player is currently in. So we can do 2 things. We can either ask the question, did he just wander into the room the player's in? If yes, refresh the room. Or we can avoid that question and just say, every single time an NPC wanders, refresh the room. That one, just when you have a lot of NPCs, that would actually probably not be the best idea.
And a lot of calls to the database.
Refreshing the room won't be more calls to the database, because that's local. That's just
We don't need to update the database that the NPC moved.
No, because I think the way the database should remember stuff is based on the starting position of the NPC. But one weakness in our code right now will be that if you have NPCs starting in room A, and then they start wandering, and you go and add a new room and then hit save to the database, it's going to take a snapshot of your current state of your dungeon. So that NPC is now in a new room because he's been wandering. Does this kind of make sense? Because we're allowing Firebase's default action of just save my magical objects to Firebase. We're not going to solve that today, but keep in mind that if you have dudes wandering around the map and you hit save, they'll start in a new room next time. Maybe you'll luck out and they'll wander back. Okay, but this would mess up kind of boss fights and that kind of stuff. Okay, so what we did last time is we made our NPC, we turned him into a thread, right? And so an NPC has this run method then. So all threads must implement all threads have a run method so they get one that takes no parameters and does nothing. So if you choose not to write anything in there, one might question, why did you make this a thread? Why did you make this a thread? So you should implement your own public void run that has the logic in it of what you want this thread to do. Okay? So we have our NPC, right now we have them saying stuff, right? So we're modifying that. Instead of having them say things, now we're going to have them every so often go to a different exit in the room that they're in. Okay? So what I'm going to do here is when we take an exit, so we do that from a room's perspective, right? So a room has take exit, and it takes an exit in a specific direction. Now, what we do here is we pass in one of four directions, right? North, south, east, west. So what I can do is I can just keep taking exits until this guy finally returns a true. Right? I could just say, randomly generate an exit between north, south, east, west. Try to take an exit in the room you're in. I don't have to check to see what the available exits are or anything like that. So you got the zombie guy just slamming into the, well, we have an east wall. The west wall here. It's like, no, okay, I'm going to randomly generate another one, west. It's like, okay, stupid. So eventually he's going to make it out a door. All right? Unless you're in a room with no doors. Or you're just really, really, really unlucky. Something like that. All right? So we already have a function called takeExit that as long as we pass it one of those four strings, are they all lowercase? North, south, east, west? All right, so inside of our NPC, he will know he knows his current room index. So he'll have to get the room from the dungeon for what room he's currently in, right? Okay, so we'll go ahead and keep with this guy here. I've done something. All right, we'll keep with this guy here. We're going to have the thread go to sleep for a random amount of time between 1 and almost 11 seconds. That's what we've effectively created here, right? We're going to say that's good. That's for when they wander. Okay. We're also, what I'm going to do right away in here, I'm going to let's go ahead and get the player's current room. We need to do inside the while loop because after he officially gets into a new room, his current room is now a new room. All right. So we're going to have room, cur room. And then inside this while loop, the very first thing we'll say is cur room is equal to core dot the dungeon dot. Do we have?
Actually call this dot get current room.
It's an index.
There is actually a function. I think if you scroll down.
Oh, we built it into yeah. Thank you. This dot get current room, so that will. Actually, with that in mind, we don't need to store our room object. We'll store it. That's fine. That way we don't have to call the function every time. All right, so we'll get our current room. That just does the lookup for us in the dungeon. We've written that logic previously. Then we'll go to sleep for some random amount of time, and then we will try to take an exit. So rooms let us try to take an exit. So inside here, I'll go ahead and do it up here. I'm going to say string array potential exits is equal to north, south, east, and west, like that. And so then down in here, after I've slept for a little bit, I'm going to keep randomly picking one of those four strings and trying to take the exit until it lets me. All right. So we'll say while. We'll put it into another variable.
Can we make that string array potential exit by having those, like how we have that those button in the room with the direction?
Oh, you could certainly make it. I mean, you could do this a lot of different ways. You could certainly make this limited to the exits that are only possible. But in this case, I'm just taking advantage. This is kind of like the quick way of doing it. So we'll say cur room to try. It's going to be our string here. So we're going to go ahead and say do. We're going to do loop. What? Why wouldn't? Oh, that's just evil. It won't let me put it on the next line down without spacing. Gotcha. All right, so we're going to do cur room to try is going to be equal to potential exits at bucket r dot next int, and we'll pass it a 4, which will give me a value between 0 and 3. All right, so that's going to be some string between north, south, east, and west. Who knows if that exit's going to exist? All right. So then I'm going to give myself a Boolean success. We'll set that equal to false initially. Probably didn't have to do that, but we'll say success is equal to cur room dot take exit, and we'll pass it the cur room to try. So we're going to try to take the exit of the one we just randomly picked. We'll get a response back, whether that worked or not. And we're going to keep doing this while not success. So as long as success is false, we'll keep trying to, we'll generate a brand new exit to try to take and try to take it. Eventually, we'll get dumped into the next room. So once we're out of here, we know we've moved rooms. Okay? Or the NPC was in a room that, well, then we would never get here. The NPC's in a room without exits, which in our current model doesn't exist, right? All right, so once we're here, we have successfully moved. If we've successfully moved, what do? We're going to ask, have we moved into the room that the player's currently in? All right, so we'll go ahead and I'll go ahead and let this loop back up. Okay. Let's think about that. I'm going to do this. I'm going to set this once beforehand, and then I'm going to grab it again. A little bit redundant, but necessary for what I want to do here. So after we've moved to a new room, I'm going to go ahead and update my variable for my current room. Then I'm going to ask the question, if cur room is equal to this, not this dot, core dot. Don't we have player? Core dot P? Don't have? I don't.
Or maybe in the builder, yeah.
Ew, yeah. So, yeah, so we need to do this. So we'll say player, the player, like this. And then inside of main activity, when I build my player up here, I'm just going to do this for convenience. I'll just go ahead and say core dot the player is equal to P. So inside of main activity, we can still use our local variable P, so I don't have to go and update that stuff. All right, so now back over in MPC, we can say if cur room is equivalent to core dot the player dot get current room. If those are the same room, then we'll say core dot the player. Actually, we don't even need to say that. We need to give ourselves access to the main activity so we can call his fill thing. So inside core, we need to have a public static main activity, call that main screen. And then inside of main activity, core dot main screen is equal to this as well. So we have all sorts of synonyms for that guy. And inside of here, we'll say core dot main screen dot fill. What do we call it? Oh, we made it a private function. And then don't we need to do an add exclude before that? Won't hurt anything. So we'll call it, tell it to fill the interface. With current room, because that happens to be the room that the player is currently in. So every NPC will go to sleep for some amount of time. He'll figure out where he currently is. Then he'll start randomly picking exits to try to take the exit, record whether it worked or not, do it over and over and over again as long as it didn't work. But we do have to try to take the exit once, which is why we put it inside of a do while loop, when things have to happen at least one time. All right, so eventually he'll be able to punch through and take his exit. When we get here, we'll get his current room. We'll ask, are you in the same room as the player's in? If you are, ask the main screen to go ahead and fill, update the interface. So if the player's currently sitting in there, he'll see that somebody's moved into his room. That make sense? All right, so we can go ahead and run this. Well, it doesn't matter. I think we have several players in the first room, several NPCs in the first room. So we'll just quickly move into the next room next door. That way we hopefully will see them wander in. So I'll just go north. So right now I just see CHH, FH, whatever. Think it's gonna take a while. Here, let's
Maybe go away from the sleep because they actually have.
All right, well, they've left this room.
It's like his character hunt to find him.
Oh, we would also need to update if the if the guy's previous current room was our room. So right here, if before we got the new current room, we would have to ask if cur room is equal to core dot the player dot get current room. Then we would also say fill screen. We will always say this and then move on to this, and the logic will solve itself. That way, if somebody leaves our room, we'll notice. So this should be something we could see real quick, because we'll just go into a room that has NPCs, and within 10 seconds, we should see them go. Somewhere. Not where we are. All right, so we got 3 NPCs in here. And we are telling our NPCs to start already, aren't we? Should be in our, this guy, start NPC threads. That's in dungeon. We tell each room to start his NPC threads. Yeah, they should all be cooking. Yeah, I don't know. Probably made a stupid mistake. I don't know. I'll look at it this afternoon and update the code. We've probably just done one little stupid thing. But anyways, these guys should be wandering now. We should see inside of our logcat. Yeah, actually, they're not moving. So they're not even trying to move, and I'm not sure why. Yeah, whatever. I'll check it. Because that thread logic we wrote should work. They should be going. We just need to get the threads to spin up. All right, I will, so I guess, see you when I see you. Make sure you message me tonight. Let's say if it's not up by 10 p.m., your free quiz. I actually hope to have it up in the next hour, but just so I don't forget. All right? Don't forget senior seminar presentations, final day tonight, Thursday, down in the pharmacy room from 5 until 8 p.m.